So here we're going to start talking about continuous probability distributions. So we just finished talking about discrete, where we had a few, or at least a countable number, a limited number of outcomes. With continuous distributions, we now have an infinite number of possible outcomes. The total probability, when we add them all together, is still going to be 1. We can now just work through fractions and decimals and all kinds of different options, some to infinity even. So the biggest difference is that we can now take on a range of x values as well. So before, with discrete, we were looking at one outcome and the probability of that occurring. Here we can look at a range of outcomes and what's the probability of this range as well. The probability for continuous distributions is going to be the area underneath the curve. So we're going to talk about these three types. If we have a normal distribution, what is the area that is underneath here, all the way out to the tails? This entire area is going to equal 1, and we're going to be looking at the probability of one slice occurring compared to the rest. The same here. So if it's uniform, what is the area that is underneath here? The area that is underneath this curve. That is the probability for continuous distributions. We're going to start looking at uniform distributions. So this is a lot like our discrete uniform, except we have endless chunks within this group to look at. So when we were looking at dice, a 6-sided dice has 6 options within this. We can now have a 1.5 or a 1.3 or a 2.7 within this. So any slice in between here, but we do add boundaries. If there is no boundaries, then this line would just go to infinity on both sides. So our parameters is an upper limit and a lower limit. Our probability distribution is 1 divided by b minus a, so upper minus lower. Our range is what is the probability that falls here compared to the upper and lower limits. Our mean is going to be a straight average, which isn't that exciting. So if we take an average of this or an average of this, okay, the expected is right in the middle. Standard deviation all the way through there. So I want to point something out before we move on. There is a big difference in all of these when it comes to uniform distributions. So here I'm looking at the probability of x that falls between 17 and 22 and not equal to either one of them. In this case, I have the what's probability of x, and it could range from 17 and be 17 up to 22, but not actually equal 22. Same here. I'm not going to equal 17, so it has to be above 17, but can equal 22. And here the range includes both 17 and 22. So the dentist office example is the one that we are going to look at. So when you go to the dentist office, painkiller kicks in uniformly between 15 and 30 minutes. So there is an equal chance that the painkiller is going to kick in for you at 16 minutes, 17 minutes, 18 minutes, 18 and a half minutes, 18 and 3/4 minutes, 19 minutes, 25 and a half minutes. There's an equal chance throughout that time period. So we are going to look in Excel on how we would calculate this. So we have our max of 30, our minimum of 15 minutes. So that means that our range is 15, 30 minus 15. Our probability distribution in this case is going to be 1 divided by that range. So this is the probability throughout. The area to calculate, it's kind of a no-brainer. It's going to be the range times the probability distribution, which based on how we figured that, of course it's going to be 1. So the area is the probability. So we have to draw pictures. If we want to understand the probability of it kicking in greater than 19 minutes. So it's going to take longer than 19 minutes to kick in. So that means that between 15 and 30, if this is 19, we are looking at what is the probability of it happening within this range. So we're just going to say 30 minus 19. So the area is 11. To find the probability of that happening, we are going to take 11 times our probability distribution function. And there is a 73% chance of the painkiller kicking in 19 minutes or later for you. So in this case, we are looking at the probability of it kicking in less than 22 minutes. So we're going to take 22 minus 15. And again, going back to our picture, we are now on this side. So this would be 22, and we're seeing what is the probability of this happening on this side. Oop, Excel. So again, it's going to equal the area times the probability distribution. And there's a 47-ish chance of this probability occurring. We can also look at a range. So we can say, what is the chance of it occurring within a certain parameter? So even though this is our overarching idea, we can look at a sliver and say, what is the probability of this part actually happening? In which case there is 2 between 20 and 18. So again, I'm going to take 2 times the probability distribution function, and we now have about a 13% chance of that happening. We can look at the probability of 33 happening, except when we go here, 33 isn't in our range. So the chance of it happening within 33 is 0. It's not even in our area that we've given. So that is also 0. The expected value is going to be calculated by looking at our max minus our minimum divided by 2. So 7.5 is our expected.